Hey everybody, it's Miss Hunt and I'm going to do some dihybrids today. So let's go ahead and go into the Google Classroom. Everything's taking a bit. And we're looking at Friday's lesson. So going in here. Okay, Friday I have this dihybrid worksheet for you to edit and try to do. And I also have a video here to kind of walk you through it again, but I'm making this video to help you out because I feel like it's a little bit challenging. So I'm going to go to my Elmo here and I'm going to draw it up for you because you guys know how I like to draw. Okay. All right, so here is our dihybrid. And what we're talking about with dihybrids, and first of all, there's that root word di meaning two. We've been doing monohybrids in class, but dihybrids are two traits that we're going to cross together. So we're going to look at rabbits. In rabbits, gray hair is dominant to white hair. And also in rabbits, black eyes are dominant to red eyes. And so here we have the genotypes. And we're supposed to list the phenotype. So let's look at this one real quick. We have a heterozygous and then a homozygous recessive. So big G, little g. Anytime we have a capital letter, we're going to have a gray. So you guys can see that right there. And then the little b, we have red eyes. So we're inheriting gray hair, red eyes with this trait. So you can see that's what the dihybrid means, two traits. So hair color and eye color. Okay. We have two homozygous recessives. So little g, white hair. And then little b, red eyes. Okay, the next one, we have little g, and big B. So we have a white hair and black eyes. Anytime we have a capital letter B, we have black eyes. All right, and the next one, two heterozygous for both traits. We have a capital G, so we have to have gray hair, and a capital B, so we have black eyes. Okay. All right, now we're going to get into the problem. Excuse me. A male rabbit with a genotype, homozygous dominant and homozygous recessive, is crossed with a female rabbit of the genotype homozygous recessive and heterozygous. All right, and we have our square set up. Now, they went ahead and given us our letters here, but I'm going to show you where they got these from, okay? So let's take this first parent, big G, little b. So what it's asking is, when this cell does meiosis, what are the offspring going to inherit? So every offspring is going to inherit a big G because that's all he has to give. And everyone is going to inherit a little b. That's it. Now I could write this 4 times because there is 4 eggs or 4 sperm in meiosis, but I just really have to write it once. Okay, so that's what they've done over here, and they've written it 4 times. So 1, 2, 3, 4. And a dihybrid, we're doing a 4x4 box, so a lot bigger. All right, the second parent is homozygous recessive and then heterozygous. So every egg or sperm would inherit a little g, so everybody gets a little g. And then some of them will inherit the big B, and the other half will inherit the little b. So again, I could write this 2 times. I could say this and this. Okay, that's what they've written over here. So they've done 2 and then 2. So this one's going to be repetitive. All right, inside of each box, we're going to write all 4 letters. We'll keep the letters together, and we always write the capital letter first. So we're going to go big G, little g, big B, little b. Okay, we finish filling all of these in. Okay. And then these two will be similar. You're thinking to yourself, do I have to fill all of them out? Yes, in the beginning. When we get better at stuff, we can use our brain a little bit more. Okay. All right, now let's do the probability over here. How many out of 16 have gray fur and black eyes? So remember, every time they have a capital G, they have gray fur. And every time they have a capital B, we have black eyes. I like to cross them off when I count it so I don't count them over and over. So 1, 2, 3, 4, 5, 6, 7, 8. 8 have this combination. How many have gray? And that's again the capital G. And red eyes. This is all little b's. So that's all these down here. 1, 2, 3, 4, 5, 6, 7, 8. How many have white fur, little g? There you go. And that would be none. And how many have the white fur, red eyes? That's none. Okay. So that's how we answered that question. It's done. That was a pretty easy one. Okay. Let's do number 3 together. Okay. A male rabbit has a genotype of heterozygous, and he's crossed with a female of the genotype heterozygous. Okay, this one is a more fun one because they're different offspring. So I've written up the genotypes. Both parents are this. So let's talk about how we get our 4 meiosis. So I know I have to have a big G or a little g, and a big B or little b. So in math, we use the word FOIL when we're factoring. It stands for first, outside, inside, and then last. I'm going to use that same method here to make sure that I got everyone. Now, I can also see everybody's got to have a big G or little g. So I could say, well, this guy's going with this one, and this one's going with that one, and then this one has to go with that one, and that one has to go with this one. You can definitely write down your 4, especially if you can see it in your head. Just write them down. The FOIL method makes sure that I don't miss one or forget one. So the FOIL method goes first. So that's going to be these two. So I'm going to write big G, big B. Outside. So I'm going to write big G, little b. Inside, little g, big B. And then finally last, the little g and little b. Okay? And that's what they've put right here. So they've put the big G, big B. That's where they got it from, using this method right here. Big G, little b, big B, and then little g, little b. And then we're doing the same thing because both parents are heterozygous. So putting both parents from meiosis, putting them on the side, the gametes that they would inherit. Okay. If you always do the FOIL method, then they'll always have the same pattern. And this guy right here will always be your homozygous recessives. So it kind of makes it easier if you do the FOIL method and lay them all out this way. Okay. All right, let's go ahead and fill in those boxes. Okay. All right, so yours should look similar to mine, probably nicer and neater than mine. And let's go through here. How many have gray fur? So I'm reminding myself, gray, I need a capital letter, capital G. And black eyes, I need a capital B. I like to just remind myself. Okay. I'm going to go through here and cross them off. Anybody who has a capital G or a capital B. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. There's 9 of them. I'm going to put a 9 right here. Okay. How many have the gray fur, capital G, and red eyes, so little b's? Go back here. We've got 1, 2, 3. And again, you start to see this pattern emerge. If you always do the FOIL method and write them out this pattern, it'll look very similar. It'll always look this way. Okay. All right. How many have white fur? Now I'm looking for a little g, and black eyes, a capital B. Okay. I've got 1, 2, 3. Okay. And then how many have white fur, a little g, and red eyes? Red eyes is a little b. And there's just going to be 1. 1. Okay. All right. And again, he's always right here because of my pattern that I did. Okay. And that's all I have to do for this one. Now, let me give you a little note here. Anytime you're crossing dihybrid heterozygous, the ratios are always going to be 9 to 3 to 3 to 1. Most of the time, they're going to have you do a heterozygous. They always want to know phenotype. They rarely are going to ask genotype. And if you can go ahead and memorize the 9 to 3 to 3 to 1, 9 dominant dominant, 3 dominant recessive, 3 recessive dominant, 1 recessive recessive. It'll always be 9 to 3 to 3 to 1. So anytime we have 2 heterozygous, you really don't need to do the Punnett square. You just need to write 9 to 3 to 3 to 1. So that's a little clue or a little trick to do if you're smart enough to memorize it. Okay? All right. Let's see if you can do this one. Okay, this one, you need to set the gametes up yourself. Okay? All right, so I'm going to do a cross between these two, and you got to set it up yourself. So I'm going to give you a second and see what letters we're going to put here. And are you going to do the FOIL method? Okay? So I'm going to write up here. And I'm going to do first, outside, inside, and last. And yes, they repeat themselves. Okay? And that's what I'm putting down here. So I'm going to put a little g and a big B, and a little g and a little b, and then a little g big B, and a little g little b. Make sure I keep that out of there. Okay, same thing here. Doing the same meiosis, but I'm smart enough to realize everybody's getting a capital G. Everybody's getting a big B or a little b. Okay, same thing. I'm going to put it down here. I can write it twice. Okay. I could have kept these the same too. Okay. And then you're going to fill it in. Okay. All right. Hopefully that helps you understand these. We're going to try to get, I would bet we're going to get to the next page right here, these dihybrid problems. And these get a little silly on the back, okay, about these woolly haired people and spotted skin. So these get a little crazy in the back. But I would try to get here, okay? On our animals, we see a lot of dihybrids in horses, in color patterns in horses, dogs, cattle, that kind of stuff. So sometimes you're going to come across colors that you've no idea, you've never heard of them before. Chestnut or this pacing gait. These are actually real things. The gait is how a horse walks. And I know that sounds so funny that how he walks would be an inherited trait, but it is. The colors are on here too. So sometimes you run across things that you've never heard of before, but you have to just rely on your genetics and say, actually, I can figure this out. I don't really need to know what a pacing, trotting chestnut horse is. Okay, and that's dihybrids. I hope that helps you figure these out. And always email me and let me know if you have any questions. Have a great day.